Hello everyone, welcome to this problem. Today we are going to solve this integral, and this is a very interesting integral actually because of the integral and then the square root and then there is an infinite product inside as well. Okay. So as you can understand from just taking a glance at this, that what we need to basically achieve is find the value of this infinite product. So I will write it separately here. Let this be s theta. Some product of k equals to 0 to infinity cosine of theta upon 2 to the power k plus 1 by 2. So this is the infinite product that we need to find the value of. Now, so from basic trigonometry, what we can infer directly from this equation, okay, so this might be a bit hard to observe at first, but if you just ignore this theta by 2 to the power k part and consider this as an angle, so let alpha equals to theta by 2 to the power k and only focus on the expression inside the product. So that thing basically comes out to be cos alpha plus 1 by 2, right? And if you remember correctly, this is simply nothing but cosine of alpha by 2. That is the product for the half angle formulas, right? That is a formula for that. So we will use this, and in this way, our s theta should become product of k equals to 0 to infinity cosine of, so it was alpha by 2, so it would be theta by 2 to the power k divided by 2. That 2 will get absorbed in the denominator, which would result basically in theta upon 2 to the power k plus 1. Okay, so that is an infinite product. But how does that help us? Well, what we are going to do is we are going to exploit an identity and we're going to extend it in such a form that we get our answer. We'll start with the most basic function sine theta, and we'll apply the half angle formula for sine theta, which is, I will write it here. You know that sine 2x is simply 2 sine x cos x, right? 2 sine x cos x. Now consider x as theta by 2 here. So sine theta is basically sine of 2 times theta by 2, where this theta by 2 can act as our x. And this should simply give you 2 sine theta by 2 cos theta by 2, right? Again, do the same thing with sine theta by 2. What will you get? You will get something like this. 2 sine theta by 4, and there is a 2 square because there is another 2 getting absorbed in this one, cosine of theta by 4 into cosine of theta by 2. Do it again with sine theta by 4, you will get 2 cube into sine of theta by 8, cosine of theta by 8, cosine of theta by 4, cosine of theta by 2. Do you see where this is heading? So when we expanded it 3 times, what we got is 2 cube multiplied by sine of theta by 2 cube, and then from cos of theta by 2 cube all the way up to cos of theta by 2. So if we were to do it n times, like we expand it n times, what we would get is something like this. 2 to the power n sine of theta by 2 to the power n, and then there would be cos of theta by 2 to the power n into cos of theta by 2 to the power decreases, right? So if it was 2 to the power n here, it should be 2 to the power n minus 1 here, and this should go up to cos of theta by 2. That is our identity, correct? So that basically means that what we can write from this equation, since we know that this is equals to sine theta, right? What we can write is this infinite product, this finite product here basically, which can be written in the form k equals to, let's say, 0 to n minus 1 cosine of theta by 2 to the power k plus 1. Notice how the limits will manage it, because k equals to 0 will produce you a cos of theta by 2 and k equals to n minus 1 will produce you a theta upon 2 to the power n, right? So that is correct. Should basically be equal to sine theta upon 2 to the power n sine of theta by 2 to the power n. So this is what we have. If you take limits on both sides, let's say you take limit n tends to infinity, since n is just a variable here, as we have assumed, it's an positive integer. So we let n tends to infinity, right? What happens is we write this product up here. We'll evaluate it on the next step. This cosine of theta upon 2 to the power k plus 1. And what happens on the right hand side is sine theta is left out because it is not a part of the limit. But what we do evaluate is this limit. Limit n tends to infinity 2 to the power n into sine of theta by 2 to the power n. Correct? The left hand side simply becomes our required product s theta. So if you go back and see what s theta was, this was s theta. And this is what it has become because the n basically goes to infinity. And s theta becomes sine theta upon. Now, how do we evaluate this limit? So we can transform it into one of the forms we do know. So if you let y equals to 2 to the power n here, you see that y also goes to infinity. So the limit can basically be written as limit y tends to infinity sine of theta y divided by y. Now this, y tends to 0. If you let, I meant 1 upon 2 to the power n actually. That is what we want to do because, yeah, we can do y into sine of theta by y, but then again, we have to substitute for 1 by y. So we rather want y equals to 1 upon 2 to the power n. So it goes to 0 directly and we can substitute it directly here to get this form. And why do I want to get this form? Because obviously there is a standard limit extends to 0, sine x upon x, which is equal to 1, right? And this can be proved easily either using L'Hopitas or using the Taylor expansion of sin x, which is 1 x minus x cubed by 3 factorial, then plus x cubed by x to the 5 by 5 factorial, and all the odds, right? So sin is for the units. Okay. So what this will get you is sine theta upon this thing is basically equal to theta, right? So you can adjust a theta y here and a theta here, and this whole thing will go to 1. So this answer is basically sine theta by theta. And our required integral I, which was the infinite product, now simply boils down to the integral 0 to infinity sine theta by theta d theta. I'm not going to evaluate this integral because I have already shown in great detail how to do this. You can find the link to this video on the top right now. And this is basically equals to pi by 2. You can do this using Feynman's trick of integration or differentiation under the integral sign, also using counter integration or complex statistics used. Okay. So the final answer for the integral should be pi by 2. So that is just a representation of this integral. This integral comes in many forms. So that would be the answer. Okay. So if you really like this video, please do subscribe. Let me know in the comment section what you think about this. Thank you.